Hello students, how are you? Today we are going to discuss about a topic which is not in your studies but it is indirectly related to your studies and will be of some interest, which is regarding time travel. The concept of a time travel mostly confuses or in a way create interest in us, that is a time travel is possible or not. How real is it? We are going to discuss that, but before that let us create a background for that. There is a time travel paradox that if it becomes possible, what problem arises. Now let us discuss one scenario. Let us imagine one scenario. The first step you are seeing in this one I have written over there. There is a baby father with a grandfather. It is a scenario of 1980. Okay, 1980. When 1980s, let us go to that period. There you are seeing a grown-up man and a child, a baby with him. Okay, basically what scenario we are going to discuss in totality, the central character is Robert. Okay, now Robert is not even born in 1980. Now there is a small child sitting on his father's shoulders. You are seeing that small child is the father of Robert. That means that child will grow and will marry and will produce a child, and that child will be, let us see. Now you are seeing after 20 years, first we discussed the first step was in 1980. So after 20 years in 2000, you are seeing that child has grown up into a man now, and he has married already and produced another child, and in 20 you are seeing a person carrying his child on his shoulders, and this child in yellow t-shirt, what you are seeing is Robert. Okay, and Robert grows up and he does some nice research work and invents a time machine. Time machine is something sitting in which one can travel into past or future. So after 20 more years, that is in 2020, Robert has grown up and he has made one time machine sitting in which he travels into past. So he travels into way back into 1940s. In 1940s, that means he travels back 80 years back, when his grandfather, that means his father's father, was a child. He meets his own grandfather, some quarrel happens or something, he kills his grandfather. It is in 1940. Now the paradox comes into picture. See, he has traveled to past into 1940. In 1940, his own grandfather was a small child. And when he is a small child, then only if he is murdered, how he will grow up, how he will produce a child, and how that child will produce another child. That means his grandfather cannot marry because he killed him and can't be born. But now he himself has traveled to the past. This creates the paradox. For paradox, I have given a question mark there. It is not understandable that the grandfather is killed in 1940, then how in 1980 he is bearing a child again. Okay, so this was an introduction. We will get into a session today where we will be raising some questions. The questions which are of intuitive nature. That means they will make us to think for ourselves. Now at the face value, whenever we look at the questions, it may seem to answer them quickly, but let us hold on. Let us think for ourselves. No bookish learning or nothing which we have learned as just an information we have taken from some book or from our elders. Let not enter that or pollute our memory, pollute our intellect, but let us think for ourselves for some time. In this session, we are going to take few questions like what is time? Very fundamental questions. What is time? What is time travel? This is a curiosity raging out of mostly because of Hollywood movies, which extrapolate the scenarios to such an extent that we become skeptic whether all these scenarios, all this dramatization is created only for entertainment, or all these are having some scientific base to it. So what is time travel? Can time travel be ever possible? Do Hollywood movies do justice, 100% justice to physics? So we are going to discuss these questions. However, I'm going to pose some questions at you, and I'll be pausing. I'll be giving you few seconds, few minutes. So since this is a video session, you pause it, you think about those questions, and you come up with any answer. There's no right answer or wrong answer. It's not a quiz where you are getting some marks. Okay, let your brain muscles be exercised. So you think for that for some time, you pause the video and come back to it to proceed again, to listen the video further. So what are the questions which are posed at you? What is time in your opinion? Is it real? If yes, why do you think so? If no, how is it not real? Okay, as I said, I am not giving so much time here because this is a video session. You can pause the video, watch, and again you can play. Now we are coming to the question, what is time? Let us understand from the perspective, from the view angle of two great intellectual giants of scientific history, Sir Isaac Newton and Albert Einstein. Both are of two different eras in the history of science. As per Newton, time is a fired arrow which can never change its direction. Now we don't have much to understand it, or we need not invest much time in understanding this because it is the viewpoint of most of us. Now time is like one arrow. From where the arrow is shot, we don't know the source. From somewhere it came and towards somewhere it is going. We don't even know the target. What we call is the source is in past, from somewhere it is coming. Through present it's going towards future. The target also we are unaware of. So this is the common view angle about time, that it is traveling from past, through present it's going towards the future. Then Einstein says, hold on, it's not completely correct. Time is just an illusion created due to warping of space. Now see, I am not diving into the topic of what is warping of a space, general theory of relativity and all those things, but here we can understand only this point, that time is an illusion. Okay, so in one concept, according to Newton, it's very clear that time is fired in a particular direction only. It can never change its direction. It is coming from somewhere and going to somewhere, but the direction is unchangeable. And another concept, overall I am talking, another concept is time is an illusion. Now what it is, if we think a little deeper, both seems to be true to some extent. Now let us think of the concept of a time from the evolved viewpoint or current viewpoint or current status of understanding. Now time, whenever we say time, it is of two types. It can be clock time, it can be psychological time. Now only because we are not very clear all the time between these two types of time, and both of them are expressed by the same word time, we ourselves are confused. Let us see what is the minute difference between them. It's not minute difference, it's a huge difference in fact, but only because of the verbal similarity, that this also is called time, that also is called time, we ourselves are confused most of the time. The clock time is, this is the count of a repetition of a standard periodic motion which is of transactional relevance. So you read the line. What it means is, there is a periodic motion of a pendulum, let us say, tick tock. Once tick tock happens, one complete oscillation is 1 second. That is our assumption. So like that, 60 times we call that 1 minute. 60 times like that is gone, we call that 1 hour. 24 hours is a day. Like that, day, week, month, year, century, etc. we have calculated according to the periodic motion of Earth around the Sun. So basically, we have assumed a very short time as 1 unit, and various multiplications of that we have assumed as different times. And that is very much necessary, because today's session I had scheduled in Impartus at 3 p.m. So all of you were communicated that at 3 p.m. there is a schedule with the name time travel, and all of you attended. So for that time was necessary for everybody. It is for transactional purpose, right? That's what it is saying, which is of a transactional relevance. Now let us see, there is a psychological time. What it says as a definition is, this is perceptual gap between two impressions which is of a emotional consequence. Now see, it is related to our awareness. We are aware of one event. Let us say that event is a big sound. One sound happened, let us say. Some sound happened, okay. Now there was silence. Another sound occurred, okay. So this is one event, that is one event, okay. Between the event, that gap is perceived. That impression is psychological time. That impression gives rise to the concept of a psychological time. So it is rightly said, the gap between two impressions which is of emotional consequence. Why it is of emotional consequence? Because see, if you are in a very pleasant atmosphere, then you will feel that time is moving very fastly, right? But if you are in a very boring situation, like in a physics class, when it is very boring, then you can feel that time is going very slow. If the teacher is eating your brain all the time, so you will feel that time is going very slow. When the class is going to end, like that you may feel. So psychologically, the perception happens. The same amount of a time in terms of a clock time may seem to be more or less, depending on how much ease you feel in the situation. So psychological time, to be a little more specific, we must say that it is related to the awareness. In the awareness, when one event rises and the second event, another event rises, then the gap between the events is perceived as some gap, which is the psychological time, which is rightly said that it is of a emotional consequence, whereas the clock time is of a transactional relevance. So these two times are entirely different things, but in our day-to-day life, we are using, since the same word time is used for both these aspects, we are many a times confused between these. However, clock time and psychological time both are recognized as the word time. Now, time travel means what? See, in the general meaning, we can say that we are living in the present, right? If we can travel into past, or we can somehow travel into future, we will call that a time travel. And to do that, what is the condition? Condition for time travel. As the condition, I am just reading first, then I am going to explain it. The relative velocity of the observer must be comparable to the velocity of light, which is nearly equal to 3 lakh kilometers per second. Okay, now see, the speed of light is 3 lakh kilometers per second. That is, tick tock. In 1 second, it travels 3 lakh kilometers. You imagine one vehicle moving at that speed. How amazing, how huge it is per second only. If that is the speed of light, if the velocity of the observer can be more than that, the time travel is possible. Now you might be thinking that it is just saying that it is impossible. Moving at a speed faster than light is not possible. That's why time travel also is not possible. And this is only a clever way of saying that time travel is not possible. This may be our first impression. Now let's hold on. I am going to explain this thing, this sentence, but in that relative velocity is used. I'd like to clarify what relative velocity is. Suppose you are sitting in a train and the train is moving at a speed of 60 kilometers per hour towards east, let us say. Now you will perceive that if you will look outside the window, you may perceive that a tree is moving backward at a speed of 60 kilometers per hour. So the tree is, wherever it is standing there only, but you feel it with respect to you, the relative velocity of the train is 60 km per hour towards west. So relative velocity means velocity with respect to something. Now if you are sitting in a train and the train is moving at a speed of 60 km per hour towards east, then in your standard you are at a rest only, right? That is why you are perceiving yourself at a rest, but you are thinking or you are perceiving the tree traveling at a speed of 60 km per hour towards west. Then we say that the relative velocity of the tree with respect to the observer is 60 km per hour towards west. So like that, if the relative velocity of the observer can be more than light, then only time travel is possible. However, the condition to understand it more intuitively is to do the following thought experiment in which you can travel faster than light. Now we are going to do one thought experiment. Actually Einstein is said to do always thought experiments all the time, and actually he was not getting any opportunity to spend time in highly equipped labs in his earlier phase of life. He was engaged very much in thought experiments, and the outcomes of that are wonderful theories like general theory of relativity, special theory for relativity. Many wonderful concepts has come out of his brain. However, in the next few seconds we are also going to do a kind of a thought experiment. Now the thing is, in a real-time experiment, moving faster than light may not be possible, but in thought we can actually think that we are traveling faster than light. All these things are possible in thought. So that kind of experiment we are doing. The first point, what it says is, realize our experience of a daily time travel through looking at the stars in a clear night sky. Feel the wonderment. Okay, what this first statement says, let me explain. Now we are looking at the sky in the night. You imagine the scenario that you are looking at the sky at night and you are seeing the stars at the night, and you are seeing that today's sky is clear, or today's sky so many stars are visible today. You are saying all these statements, right? And whatever stars you are seeing, you feel that those things are present today. But for your information, let me say that it is found using Hubble telescope and all, that the stars are at huge distances from us. The nearest star to Earth is Alpha Centauri, which is at a distance of 4 light years from us. See, if I say the distance, I didn't say in kilometers, right? Are you confused? Light years means, see, light travels at a speed of 3 lakh kilometers per second. In 1 second only 3 lakh kilometers it passes. Okay. So in 60 seconds, how many kilometers it will be passing? 3 lakh multiplied by 60. And that huge number multiplied by 60 will be the distance traveled by light in 1 hour. And that entire number multiplied by 24 will be the distance traveled by light in 1 day. And that entire huge number multiplied by 365 will be the distance traveled by light in 1 year. That huge distance is called 1 light year, and 1 light year is the unit of distances between cosmological bodies, like distance between stars. When we measure, kilometer is a too small unit to say all those things. That's why it is said as 5 light years, 10 light years, 15 light years, like this it is said. And 1 light year is equal to that huge number. 1 light year means the distance that can be traveled by light in 1 complete year. Fine. Now in that unit, it is found that the nearest star to Earth is 4 light years away, and that is Alpha Centauri. Now there are stars which are hundreds and hundreds of light years away from us, but in average it can be said that the sky is, the night sky, the stars in average are 45 light years away from Earth. That means if you look at the sky, if you look at some stars, we feel that the stars are present right now, but from there light has traveled for 45 years to reach our eyes. That means what sky we are seeing now, that is the sky of 45 years before. 45 years ago the sky was like that. That scene we are visualizing in tonight. That means when we are looking at the sky, though we are thinking that it is the present time, we are looking at 45 years back. In different words we can say that. So whenever we are looking at the sky, we have already experienced the time travel, because what we are looking at and thinking to be present time is actually 45 years ago. This is what the first statement says. Realize our experience of a daily time travel through looking at stars in a clear night sky and feel the wonderment. Wow. Now the second point says, imagine you travel to a star doubly faster than light. View it just dying. Remember, the stars are having millions and millions of years lifespan. However, after that great big lifespan also, it dies. Every star dies and becomes a black hole, etc. Anyway, for the time being, we are not going into black holes, etc. But let us just take for granted that stars are not permanent, they are dying. Now you have traveled to a star and the star is dying, that you have viewed. So I am repeating the sentence. Imagine you travel to a star doubly faster than light, view it just dying, return to Earth with the same tremendous speed, and predict the death of the star in future to the people on Earth. This is called time travel. Now the second point, if you have grasped, that's wonderful, but if you didn't grasp it completely, you will be getting the perfect understanding in the coming video through a little visual explanation. Let us imagine this is the Earth and this is the nearest star to us, which is Alpha Centauri, and as I have mentioned already, it is 4 light years away from us. Now let us imagine you have designed a rocket and which goes 4 times faster than light, let us say. So the jet travels 4 times faster than light means what? From Earth to Alpha Centauri, you will travel in the jet in how much time? 4 light years. You will travel in 1 year only, yes or no? So 4 light years distance, you will reach the Alpha Centauri in 1 year only. But light itself will take 4 years to travel this much distance, but you can travel it in 1 year only. And in another 1 year, you will return from Alpha Centauri, right? So you will go from Earth to Alpha Centauri in 1 year, and you will return from Alpha Centauri back to Earth in another year. So in 2 years time, you can go from Earth to Alpha Centauri and return to Earth again. However, in 2 years it happened, but the light from Alpha Centauri when travels, that will take 4 years to reach Earth. And if some light reaches on Earth and falls in the retina of our eye, then only we will be able to sense the Alpha Centauri, yes or no? Now, suppose you have started traveling in the jet, and then the light is traveling, the small arrows moving slowly, you are seeing, that is the speed of light. Light will reach the Earth after 4 years, but in 2 years only you came back to Earth. You have viewed already the Alpha Centauri and you came back to Earth, and to the people you are saying that whatever you have viewed there, you are saying that thing. If Alpha Centauri has dying, it is dying, or it will die, whatever you are saying, that thing what you have viewed. But what you said, the people of Earth will view that after 2 more years, because light has traveled half distance only in 2 years. It will take another 2 years to reach Earth. So whatever the person, the observer in the rocket says just now, that will happen for the people of Earth, people on Earth after 2 years. So the people on Earth, like we smart people, we will react like this: wow, the scientist has traveled into future, we'll say. You understood now what actually is time travel? So again, going back to those questions what we raised initially, is time travel possible? Yes, but with the condition that one has to travel faster than light. And if that is possible, one can travel faster than light, then also only it is past, it is the same thing, the happening at the present only, but from some standpoint the same thing is past, from some standpoint the same thing is future, and to some standpoint, for some standpoint, it is the present itself. So this is actually the truth of time travel. And as far as the other question we discussed, that the movies, whether they are doing 100% justice to physics or not, actually their purpose is different. When you make a movie, the purpose is how to make it interesting, right? So various factors are coming into picture. So 100% doing justice to science 100% is not possible over there. So if we are coming across stories like you go time travel to past and you meet a very young and beautiful girl there, you fall in love, and later on you discover that that girl was your mother. These kind of a lot of paradoxes you find in various movies, and those ideas are only for the purpose of creating interest, but they are not in 100% sync with the science. Now that you are very aware what time travel is, without going into any calculation involved in general theory of relativity or special theory of relativity, still we are having a very strong intellectual understanding now what time travel is, and we can perceive how real it is and what is the possibility and how it is possible. We need not think it to be something mysterious, right? It's not mystical anymore. It is possible only, but this way it is possible, not in the way it is predicted in some of the movies, etc. Right? The two simplified presentation is directly or indirectly based on the following resources. 1. Arrow of a Time by Professor Stephen Hawking. The unique intellectual giant is no more with us. He was the director of research at the Center of the Theoretical Cosmology at the University of Cambridge at the time of his death. Second, some of the themes of Hollywood movies like Star Trek, Back into Future. And third point, some general explanations were considered by Professor Michio Kaku, a senior professor at this time at the City College of New York, and Professor Brian Greene, also senior professor in Columbia University, USA. So thank you everybody for your kind attention.